Hello there, and welcome. I'm so glad you found your way here tonight. Tonight we're going to drift through a mystery that spans decades, a story connecting a famous signal from 1977 with an interstellar visitor discovered only recently. Let's begin with a night in August 1977, when a computer heard something that shouldn't have been there. Picture a large radio telescope in Ohio, its massive ear turned toward the cosmos listening. Not for sounds the way you and I hear them, but for radio waves washing across Earth from distant corners of the universe. Most nights brought only the gentle hiss of background radiation, the static murmur of a mostly quiet cosmos. But on August 15th, something changed. The Big Ear radio telescope was doing what it always did, slowly scanning the sky as Earth rotated beneath the stars. Its receivers were tuned to a very specific frequency, one astronomers call the hydrogen line, at 1420 MHz. This isn't just any frequency. Hydrogen is the most common element in existence, the building block of stars, the foundation of chemistry itself. When neutral hydrogen atoms flip their electron spin, they release energy at this exact wavelength. It's a frequency every technological civilization would know, a cosmic landmark as obvious as the North Star once was to sailors crossing dark oceans. And on this particular night, at 23 minutes past 11 Eastern Time, the telescope detected something extraordinary. The signal strength rose smoothly, peaked, then fell away in a perfect bell curve lasting 72 seconds. This pattern wasn't random, it was exactly what you'd expect from a point source in space, something specific and distant, passing through the telescope's field of view as Earth turned. The computer recorded it as a sequence of characters representing intensity, 6EQUJ5. These letters and numbers climbed higher than anything the system normally detected, 30 times stronger than the background noise, concentrated in a band narrower than 10 kHz. Days later, a volunteer astronomer named Jerry Eman was reviewing the computer printouts. Imagine him there, sitting at a desk with stacks of paper covered in columns of numbers and letters, most of them unremarkable, most showing nothing but the expected cosmic static hour after hour of this work, scanning for patterns that probably weren't there. And then his eye caught that sequence, 6EQUJ5. His breath must have caught. He grabbed a red pen, circled the characters, and in the margin wrote a single word that would define this mystery for decades to come. He wrote, "Wow!" That exclamation, that moment of recognition, gave the signal its name, the WOW signal. And in the nearly 50 years since, no one has been able to fully explain what Jerry Eman saw that night. Let's drift into why this matters, why this particular detection has haunted the scientific community for so long. The signal had every characteristic researchers look for when searching for extraterrestrial intelligence. It was narrowband, meaning it occupied a tiny sliver of the radio spectrum, far too focused to come from natural astrophysical processes like pulsars or quasars. It came from a specific direction in space, from coordinates in the constellation Sagittarius toward the galactic plane. Though not from any known star or obvious celestial object, it arrived at the hydrogen line frequency, that cosmic waterhole where any civilization studying the universe would naturally look and listen, and then it vanished. Never detected again, despite more than 100 follow-up observations using various telescopes. Some more powerful than Big Ear astronomers pointed their instruments at those same coordinates, listened at that same frequency, searched and searched through the decades. Nothing. Only silence. The signal appeared once, like a voice calling out in a dark forest, then fading before you could determine which direction it came from, or whether you'd really heard it at all. Think about what makes something like this so compelling. We have physical evidence, an actual printout that still exists in the Ohio History Connection archives, Jerry Eman's handwritten "Wow," still visible in red ink. This wasn't someone's imagination, or a story passed down through generations. It happened. Something caused that telescope to record those values. The question isn't whether the detection occurred, but what it means. Over the years, scientists have proposed various explanations. Perhaps it was terrestrial interference, some Earth-based radio transmission that somehow passed through all the filters designed to screen such things out. But the frequency was protected, internationally restricted, and the signal characteristics didn't match known interference patterns. Maybe it was a reflection off space debris, bouncing some signal from Earth back toward us, but that can't explain the precise frequency or the narrowband nature. In 2017, a researcher suggested it might have come from cometary hydrogen clouds, but this explanation was widely disputed because natural hydrogen emissions are too weak and too broad to match what was observed. Right now, as you lie there listening, that original printout sits in an archive, a piece of paper that represents one of the great mysteries of our time, 6 characters and an exclamation mark, a whisper from 1977 that we still don't fully understand. It's like finding a message in a bottle washed up on a beach, written in a language that looks almost familiar, but whose meaning remains just beyond comprehension. So there it is, the wow signal. One moment, one transmission, one enduring mystery. For over 4 decades, scientists have wondered what caused it and why it never repeated. But what if the answer isn't in the sky where we've been looking, but in an object we didn't discover until 2019? What if the messenger arrived decades after the message? Let's drift toward that possibility now. Now we leap forward from 1977 to December 2019, when astronomers discovered something unusual entering our solar system. The second thread of our story begins not with a signal, but with a visitor, an object from the space between stars. On December 29th, telescopes in Hawaii detected a faint point of light moving against the background of distant stars. At first, it seemed like just another comet, one of the countless icy wanderers that orbit our sun. But as astronomers tracked its path and calculated its trajectory, they realized something remarkable. This object wasn't orbiting the sun at all. It was passing through, following what mathematicians call a hyperbolic orbit, the kind of path that means you're just visiting, never to return. They designated it C/2019 Me4, named for the Atlas survey system that found it. But as more observations came in, and its true nature became clear, it earned a different designation, one that marks it as Special 3I Atlas. The third confirmed interstellar object ever detected passing through our solar system. Let's drift into what that means. Until 2017, we had never confirmed an interstellar visitor. We suspected they existed, knew theoretically that comets and asteroids ejected from other star systems must occasionally wander through our cosmic neighbourhood, but we'd never actually seen one, never caught one in the act of passing through. Then came Oumuamua in 2017, that strange elongated object that sparked so much debate, then 2I/Borisov in 2019, clearly a comet with a visible tail, and then, just months later, 3I Atlas. Imagine what it means for an object to be truly interstellar. The space between stars is vast beyond human comprehension. Our nearest stellar neighbour, Proxima Centauri, lies more than 4 light-years away. An object travelling at 30 or 40 kilometres per second, which is extraordinarily fast by our everyday standards, would still take tens of thousands of years to cross just 1 light-year. 3I Atlas potentially wandered through that immense darkness for millions of years, drifting in the cold and silence far from any sun's warmth, before gravity drew it into our solar system. Think of it as a cosmic tumbleweed rolling across an infinite desert, blown by ancient stellar winds. It rolls for years, decades, centuries, eventually reaching a small oasis, our solar system. It passes through, touches the warmth of our sun briefly, then continues into the desert on the other side, carrying no memory of us, no awareness that anyone noticed its passage. As 3I Atlas approached the sun in early 2020, astronomers watched it carefully. It began to brighten and develop a visible coma, that fuzzy cloud of gas and dust that surrounds an active comet's nucleus. Spectroscopic analysis revealed familiar chemistry: water ice, carbon monoxide, carbon dioxide, the typical ingredients of comets formed in the outer reaches of planetary systems. This visitor from another star system turned out to be chemically similar to comets born here, suggesting that the processes of planetary formation might be universal, that other star systems create worlds and debris much like our own. But then something unexpected happened. In May 2020, as it drew closer to the sun, 3I Atlas began to disintegrate. The Hubble Space Telescope captured images of it breaking into multiple fragments, likely torn apart by thermal stress as solar heating created pressure within its icy structure. Some comets are solid, cohesive objects that can withstand the sun's heat. Others are loosely bound rubble piles that fall apart under stress. 3I Atlas was the latter, and it fragmented before reaching its closest approach, dissolving into pieces that continued on separate trajectories, all heading back toward interstellar space. There's something both melancholy and beautiful about that ending. This object travelled for perhaps millions of years through the darkness between stars, survived the cold and radiation of interstellar space, finally approached a sun again, felt warmth for what might have been the first time in eons, and then broke apart. It will never reform, never coalesce back into a single body. Its fragments will continue outward, each one a separate traveller now heading back into that infinite night. Right now, as you lie there, other interstellar objects are passing through the space around our sun. Most go unnoticed, too faint, too far from our viewing angles, wrong timing. But they're there, silent wanderers from distant star systems, carrying within them the chemistry and history of places we'll never see. Astronomers estimate roughly one interstellar object per year passes close enough for us to potentially detect with current technology. Thousands more pass through at greater distances, invisible, unrecorded, unknown. 3I Atlas came from somewhere, a star system with its own planets, its own history, its own story. Maybe that system has living worlds. Maybe it's dead and cold, its star long since faded. We'll never know. But for a few months in late 2019 and early 2020, we got to study a tiny piece of it, a comet ancient and worn, making one last pass by a star before continuing its endless journey through the dark. So now we have both threads of our mystery, a signal from 1977 and a visitor discovered in 2019. They seem unrelated, separated by decades, different types of phenomena entirely. But what if they're not separate? What if there's a line connecting them across time? Let's meet the person who drew that line. To understand how someone connects a 1977 signal to a 2019 comet, we need to understand the person who sees connections others miss. Dr. Avi Loeb is a name that sparks different reactions depending on who you ask. To some, he's a visionary willing to ask the questions others won't. To others, he's a provocateur pushing boundaries that should remain firm. The truth, as with most things, lies somewhere in the nuanced middle. What's undeniable is his credentials. Frank B. Baird, Junior Professor of Science at Harvard University, former chair of Harvard's Astronomy department for nearly a decade, founding director of Harvard's Black Hole Initiative, over 1,000 published papers with more than 100,000 citations. By any measure, this is someone who has earned the right to be heard. His research spans some of the most fundamental questions in astrophysics. The formation of the first stars in the early universe, billions of years ago when the cosmos was young and simple. Black holes, and their role in shaping galaxies across cosmic time. Gravitational waves rippling through the fabric of space-time itself. These are serious topics, studied with mathematical rigor and observational precision. This isn't someone working on the fringes. This is mainstream, respected astrophysics. But in recent years, Loeb has become equally known for something else, for his willingness to publicly explore ideas that most scientists consider privately, but rarely discuss openly. The hypothesis that made him a household name among science enthusiasts came in 2017, when astronomers detected that first confirmed interstellar visitor, Oumuamua. That strange elongated object exhibited peculiar characteristics. It accelerated away from the sun without any visible comet tail, without the outgassing that would explain such acceleration. Its shape appeared highly unusual, at least 6 times longer than it was wide, possibly even more extreme. Its reflectivity suggested an odd surface composition. Most astronomers proposed natural explanations. Perhaps it was outgassing in a way we couldn't detect. Perhaps its shape was less extreme than initial estimates suggested. Loeb, along with his colleague Shmuel Bialy, published a paper suggesting they should also consider another possibility. What if Oumuamua was artificial? What if it was a light sail, a piece of technology from another civilization, tumbling through space on a journey whose origin and purpose we could never know. The reaction was swift and divided. Some praised the boldness of considering all possibilities, others criticised what they saw as sensationalism, as lowering the standards of scientific discourse. Loeb's position remained consistent throughout. We should consider all hypotheses, he argued, including artificial origin, and let the data decide. Extraordinary claims need extraordinary evidence, absolutely, but we should at least look for that evidence rather than dismissing possibilities out of hand. This philosophical approach defines much of Loeb's recent work. He founded the Galileo Project in 2021, a systematic scientific study of unidentified aerial phenomena and interstellar objects, searching for potential technological signatures with transparency and data-driven analysis. He advocates for what he calls exploring low probability but high-impact hypotheses. The argument goes something like this. If you only study safe, incremental questions, you make safe, incremental progress. But the universe occasionally surprises us with phenomena we didn't expect. Being open to those surprises, being willing to investigate the unlikely, sometimes leads to discoveries that change everything. Think of Loeb as a detective at a crime scene. Most detectives start with the most common explanations: robbery, accident, familiar suspects. These are good starting points because they're usually correct. But imagine one detective who also asks, what if this was something we've never seen before? That detective might be wrong 99 times out of 100. Their colleagues might find them exhausting. But that one time they're right. They solve the unsolvable case, the one everyone else had given up on because the answer didn't fit conventional patterns. The scientific community's response to Loeb reflects an ongoing tension in how science progresses. Should researchers be conservative, building carefully on established knowledge, avoiding speculation that might mislead? Or should they be bold, willing to explore fringe ideas because occasionally those ideas turn out to be revolutionary? The answer, perhaps, is that we need both. We need the careful incrementalists filling in details and testing theories rigorously. We also need the boundary pushers asking uncomfortable questions and looking in unexpected places. Loeb has chosen to be the latter, accepting both the criticism and the freedom that comes with that choice. What matters for our story tonight is understanding that the hypothesis we're exploring comes from someone who has earned scientific credibility through decades of conventional research, but who has also demonstrated a willingness to propose ideas that others consider too speculative. You don't have to believe everything Avi Loeb suggests. Many scientists don't. But his ideas are worth considering, worth examining, worth wondering about as the night deepens and sleep approaches. So now you know the mind behind the hypothesis. Brilliant, bold, controversial, unafraid of criticism. With that context, we can finally explore the connection he made between our two threads, the 1977 signal and the 2019 visitor. How do you link them across 42 years? It starts with mathematics and a calculation that yields a very unexpected result. Now we arrive at the heart of the mystery. Let's drift into the mathematics gently, seeing how Loeb traced 3i Atlas backward through time. Orbital mechanics is a peculiar kind of time travel, not the science fiction variety where you step into a machine and emerge in a different era, but something more subtle and more real. When you know where an object is right now and how it's moving, the laws of physics allow you to calculate backward. You can determine where it was yesterday, last week, last year, decades ago. The equations are elegant in their simplicity. Newton's laws of motion, refined by Einstein but fundamentally unchanged, for objects moving at everyday speeds through ordinary space gravity pulls, objects move. The dance is predictable, mathematical, knowable. Loeb began with what astronomers knew about 3i Atlas in 2019 and 2020. Its position as it passed through the inner solar system, its velocity, that speed and direction through space that marked it as interstellar, its trajectory, that hyperbolic path showing it was just passing through, never to return. With these numbers in hand, he set out to answer a simple question. Where was this object in August 1977? The calculation required accounting for multiple factors. The sun's immense gravitational pull, dominant in our solar system, constantly tugging on the comet's path. The smaller but still significant perturbations from Jupiter and Saturn, those giant planets whose gravity nudges anything passing nearby. The object's own velocity through interstellar space, that momentum it carried from whatever star system ejected it millions of years ago, feed all these variables into the equations, let the computer work through the mathematics step by step, and a path emerges, extending backward through time. The result was startling. In August 1977, according to these calculations, 3I Atlas would have been in the direction of the constellation Sagittarius. More specifically, it would have been positioned within or very near the coordinates where the WOW signal originated, the same patch of sky, separated by 42 years, but connected by orbital mechanics and the patient mathematics of celestial motion. Let's pause here and consider what this means. The sky's vast, containing more than 41,000 square degrees. The uncertainty box around the WOW, signal coordinates, accounting for the limitations of Big Ear's observational precision, covers perhaps 1 square degree, maybe slightly more. Finding an object randomly positioned in that specific box is like dropping a pin on a globe and having it land on a particular city block. The probability is extraordinarily low. Loeb calculated the odds, taking into account the solid angle of the WOW signal region compared to the full celestial sphere, accounting for the uncertainties in both the signal's coordinates and the comet's reconstructed position. He arrived at a figure. The probability that this alignment is pure coincidence, according to his analysis, is approximately 1%, which means there's roughly a 99% chance that the correlation is meaningful, that something connects these two phenomena across 4 decades. Think of it like retracing someone's footsteps. Imagine a detective examining security camera footage, watching a car speed away from a crime scene. The detective knows where the car is now and can see which direction it came from. Frame by frame, the analyst rewinds the footage, tracking backward through city streets, through turns and straightaways, until eventually placing that car at the crime scene at the precise moment the crime occurred. That's what Loeb did with 3I Atlas, rewinding its cosmic journey until he found it in the right place at the right time. Of course, these calculations involve uncertainties. Small errors in measuring the comet's velocity or position in 2019 amplify as you calculate backward through decades. Gravitational perturbations from distant planets or unseen objects could have nudged the trajectory in ways we can't account for. The further back you trace, the larger the uncertainty becomes. By the time you reach 1977, 42 years before the observation, those error bars have grown substantial. But even accounting for all these uncertainties, the alignment holds. The math keeps pointing to the same conclusion. There's something almost haunting about this discovery. In 1977, before we'd found a single planet beyond our solar system, before we knew interstellar objects visited us, something was passing through that exact region of sky. It may have been close, perhaps 5 to 10 astronomical units from Earth, somewhere between the orbits of Jupiter and Saturn, close enough that a radio transmission would arrive strong, concentrated, briefly brilliant, and we heard it. Jerry Eamon saw those characters on the printout and wrote his exclamation of wonder, but we didn't understand what we were hearing, didn't know the messenger existed until decades later when we finally spotted it leaving. It's like receiving a letter with no return address, wondering for 40 years who sent it, then discovering the person who mailed it was walking past your house the exact day it arrived in your mailbox. But by the time you realise this, they're already gone, moved away, unreachable. The message and the messenger were both there, both present, both real. We just didn't see the connection until it was too late to do anything about it, so the mathematics say 99% chance this isn't coincidence. But mathematics alone don't explain how or why. If 3I Atlas really did send the WOW signal, the next question becomes even more fascinating and strange. How would a comet produce a narrowband radio transmission? Let's drift toward that mystery now. If an interstellar comet sent a signal, how would that work? Let's explore the possibilities gently, without rushing toward answers that might not exist. Comets are ancient, simple objects, ice and rock and dust, bound together loosely, leftovers from the formation of planetary systems billions of years ago. When they approach a star, the ice begins to sublime, turning directly from solid to gas, creating that characteristic fuzzy coma and sometimes a tail streaming away from the sun. This process releases molecules into space, water vapor, carbon monoxide, hydroxyl radicals, cyanide compounds. These molecules emit light and radio waves as they interact with solar radiation and the solar wind. We've studied many comets over the decades, both from our solar system and now these interstellar visitors, and we understand their emissions reasonably well. Here's the challenge. All natural comet emissions are broadband. They spread across wide swaths of the electromagnetic spectrum, diffuse and scattered. The wow signal, by contrast, was extraordinarily narrowband, concentrated in a frequency range narrower than 10 kHz. That kind of specificity, that focused emission at one particular frequency, doesn't match any known natural process in comets. It's like the difference between the broad wash of white noise from a waterfall and the pure tone of a tuning fork nature tends to produce waterfalls. Tuning forks require something more deliberate. So if 3i Atlas truly was positioned where the calculations suggest in August 1977, and if it really did produce that signal, we're faced with several possibilities. The first possibility is that some natural mechanism exists that we simply haven't discovered yet. Perhaps under very specific conditions, when an interstellar comet, carrying particular chemistry, interacts with the solar wind at just the right distance from the Sun, something unusual happens. Some kind of Meister effect, where molecules align in specific ways and amplify radiation at particular frequencies. Natural mesas do exist in the universe. We find them in star-forming regions where water or hydroxyl molecules create coherent microwave emission, but we've never observed anything like this from a comet. No comet we've studied, and we've studied many, has produced narrowband radio emission remotely resembling the wow signal. This doesn't mean it's impossible. The universe has surprised us before with phenomena we didn't expect. Pulsars, when first discovered, were so regular and precise that astronomers briefly considered whether they might be artificial beacons before realizing they were rapidly rotating neutron stars. Fast radio bursts mystified researchers for years until we began understanding their origins. Nature is capable of extraordinary things. Perhaps comets, under rare conditions we haven't witnessed, can produce focused radio transmission. It seems unlikely given everything we know, but unlikely isn't the same as impossible. The second possibility is more speculative, more unsettling in its implications, and yet not physically impossible. What if the comet carried something artificial? Not that the comet itself was artificial, but that it served as transport, as camouflage, as a slow ship travelling between stars. Imagine a technological civilization deciding to explore the galaxy not with fast, fragile spacecraft, but by embedding probes in comets, objects that naturally wander between star systems over millions of years. The ice provides radiation shielding. The natural appearance provides camouflage. No fuel is needed because gravity does the work over vast timescales. The probe hibernates through the long darkness of interstellar space, then activates when sensors detect it's approaching a star system. Once active, it might transmit a signal, a test to see if anyone is listening. A hello cast into the void at the one frequency any technological civilization would monitor, that hydrogen line at 1420 MHz. If it receives a response, perhaps it begins a more complex communication. If it detects no response, it continues on its journey, falling silent again, moving toward the next star system in a mission that could last millions of years. This scenario sounds like science fiction, and perhaps it is, but nothing about it violates known physics. It's technically feasible with technology not vastly beyond what we ourselves could imagine building in a few centuries. The power requirements Loeb calculated, about a gigawatt for the signal strength detected to Earth from the estimated distance of 3 Atlas in 1977, are substantial but not impossible, is comparable to the output of a large power plant concentrated into a directional beam sweeping through space. Which brings us to another puzzle. If something on 3i Atlas was transmitting, why did we hear it only once for only 72 seconds? One possibility is rotation. Imagine a lighthouse on a distant shore, its beams sweeping in circles. You see the light for just a moment as it crosses your position, then darkness returns as it rotates away. A probe on a tumbling comet might work the same way, its antenna or emission mechanism pointing in one direction, the comet's rotation carrying that beam across Earth briefly before it pointed elsewhere. Another possibility is that we simply weren't looking most of the time. The Big Ear telescope only observed that patch of sky for 72 seconds as Earth's rotation carried it through the telescope's fixed field of view. If the transmission lasted longer, we would have missed most of it. If it transmitted multiple times at different intervals, we might have caught only one burst during a moment when we happened to be listening. The universe is vast, and we're watching only tiny portions of it at any given time. We could miss a great deal, or perhaps the signal was a one-time event, a brief test, a momentary announcement that quickly exhausted whatever limited power source it had access to. Or maybe, and this is perhaps the most intriguing possibility, it was waiting for a response. It sent a signal. No answer came, so it fell silent and continued on its journey, noting in whatever memory it possessed that this star system, this yellow sun with its collection of rocky and gaseous worlds, contained no one who responded to the greeting. Let these ideas wash over you without feeling the need to reach conclusions. The mystery doesn't demand resolution tonight. It's enough to wonder, to consider the possibilities, to feel that gentle vertigo that comes from contemplating how much we don't know about the universe we inhabit. Somewhere out there, 3i Atlas is continuing its journey, its fragments spreading gradually as they coast through the outer solar system and beyond. If it carried secrets, it's taking them back into the interstellar dark, back into that vast silence between stars where most of space exists. And so we're left with this strange correlation, this mathematical connection between a 1977 signal and a 2019 discovery, with no certain way to know if they're truly related or simply a remarkable coincidence. But the story deepens still. There are other aspects to consider, other pieces of this puzzle. Let's continue drifting through them. Every bold hypothesis in science faces scrutiny, and Loeb's connection between 3i Atlas and the WOW signal has been no exception. Let's drift through the responses, the questions raised, the skepticism that meets any extraordinary claim. The scientific community's reaction has been characteristically divided. Some researchers find the mathematical correlation intriguing enough to warrant further investigation. The 99% probability calculation, if accurate, does suggest something worth examining more closely. After all, science progresses by following unexpected patterns, by investigating anomalies that don't fit our existing understanding. The alignment between the comet's reconstructed 1977 position and the WOW signal coordinates is, at minimum, a remarkable coincidence worth documenting and discussing. But many astronomers have expressed significant reservations. The concerns fall into several categories, each one representing a genuine challenge to the hypothesis that must be addressed honestly if we're to evaluate this mystery fairly. The first major concern involves the trajectory calculations themselves. While orbital mechanics is precise when dealing with short timescales and well-characterized objects, uncertainty grows substantially when calculating backward through decades. Small errors in measuring 3A Atlas's velocity or position in 2019 compound dramatically over 42 years. The further back you trace, the larger the error bars become. Some scientists argue that by the time you reach 1977, the uncertainty in the comet's position could be several degrees of arc, potentially larger than the coincidence Loeb is claiming. The object might have been in the general direction of Sagittarius. Yes, but was it really within the specific coordinate box of the WOW signal, or is that precision illusory, an artifact of underestimating the uncertainties? The second concern centers on the transmission mechanism. As we explored earlier, comets don't naturally produce narrowband radio signals. Every comet ever studied emits only broadband radiation when outgassing, along with optical light reflected and scattered from dust. The narrowband nature of the WOW signal is its defining characteristic, the feature that made it so compelling in the first place. For 3i Atlas to have produced that signal either requires discovering entirely new physics of cometary emission, which seems extraordinarily unlikely, given how well we understand these processes, or invoking the presence of technology, which takes us into the realm of speculation about extraterrestrial probes. Many scientists argue that invoking unknown physics or alien technology to explain a correlation is premature when we haven't exhausted more mundane explanations, including simple coincidence. Recent observations have added complexity to the picture. In late 2025, radio telescopes including Meerkat in South Africa detected radio emissions from 3E Atlas. This initially sparked excitement among those following Loeb's hypothesis, a radio signal from the comet just as predicted. But detailed analysis revealed something important. The emissions weren't narrowband, artificial-looking transmissions. They were the natural signature of hydroxyl radicals, OH molecules formed when water vapor breaking down in the comet's coma interacts with solar radiation. This is exactly what you'd expect from normal cometary activity during perihelion, when the comet is closest to the Sun and outgassing most vigorously. The detection confirmed that 3I Atlas is behaving like a comet, releasing water ice as it should, with no evidence of anomalous transmissions. This doesn't disprove Loeb's hypothesis entirely. If there was a transmission in 1977, it could have been a one-time event that isn't repeating now. Perhaps whatever power source enabled that broadcast decades ago is long depleted. Perhaps the geometry is wrong now, with any hypothetical transmitter pointing in a different direction as the tumbling comet rotates. Perhaps the 1977 signal came from the comet when it was in a different part of its trajectory, under different conditions. But the lack of unusual radio emissions from 3I Atlas during its current passage does weaken the case. It removes what would have been compelling supporting evidence. Other astronomers have raised questions about the statistics. Is 1% probability of coincidence really that remarkable when you consider how many potential correlations exist? Over the decades since the WOW signal, thousands of objects have passed through various regions of the sky. If you check every comet, every asteroid, every discovered object against the WOW signal coordinates, eventually you might find something that appears to align by pure chance. This is sometimes called the multiple comparisons problem. When you make many comparisons, unlikely coincidences become likely to occur somewhere in the dataset. Some scientists argue that finding one object out of thousands that seems to match is not as significant as it first appears. Yet others counter that 3I Atlas isn't just any object. It's one of only 3 confirmed interstellar visitors we've detected, making it special by definition. The calculation isn't comparing thousands of random objects, but examining whether one particular rare visitor could have been in a specific place, at a specific time. That's a different statistical question, one where the correlation might indeed be meaningful. The debate continues in papers, at conferences, in private discussions among researchers trying to understand what, if anything, this correlation means. This is how science works at its best, not by immediately accepting or rejecting bold claims, but by examining them carefully, looking for ways to test them, remaining open to surprising possibilities, while demanding solid evidence before drawing conclusions. What's important to understand as you lie there in the quiet darkness is that uncertainty isn't failure. Not knowing for certain isn't the same as knowing nothing. Science is comfortable with ambiguity, with questions that remain open, with mysteries that persist. The WOW signal has been a mystery for nearly 50 years. Whether Avi Loeb has solved it or simply added another layer to the puzzle, we may not know for years, perhaps decades. Future observations of other interstellar objects, refinements in our ability to calculate ancient trajectories, new discoveries about what comets can and cannot do, all of these might eventually provide clearer answers. For now, we drift with the uncertainty, allowing the mystery to remain mysterious, the question to stay unanswered, and perhaps there's something peaceful in that, in accepting that some things aren't yet known, may never be known, and that's perfectly all right. The universe keeps its secrets, and we keep wondering. Let's continue our exploration. Let's drift now into what this hypothesis means, whether it's ultimately proven true or remains an intriguing but unconfirmed possibility. If Avi Loeb is correct, if 3I Atlas truly was positioned near the WOW signal coordinates in 1977 and somehow transmitted that famous burst of radio energy, the implications ripple outward in ways both profound and unsettling. It would mean that humanity received a deliberate message from beyond Earth decades before we had any idea such contact was imminent. We heard it, marked it with an exclamation of wonder, and then spent nearly 50 years arguing about what it meant. all while the messenger travelled silently through our solar system, unnoticed until it was already leaving. There's something almost melancholy about that scenario. Imagine a visitor arriving at your door, knocking, waiting, receiving no answer and leaving, while you stood in another room having heard the knock but unable to determine where it came from or who might have been there. By the time you finally check, they're already gone, their car disappearing down the road, and you're left with only the memory of that knock and the eternal question of who it was and what they wanted. If the hypothesis is true, it suggests that interstellar space isn't as empty as we imagine. Objects wander between stars not just as natural debris, but potentially as carriers of deliberate messages, technological artifacts disguised as or embedded within comets and asteroids. It would mean that civilizations might communicate across the galaxy, not with powerful targeted transmissions requiring enormous energy, but with patient, slow probes that drift from star to star over millions of years, broadcasting briefly when they detect they're passing through a system, then continuing their journeys whether anyone responds or not. This method of exploration would be profoundly different from what we've imagined. No faster than light travel, no massive colony ships, no dramatic first contact, just ancient wanderers moving through the cosmic dark at natural speeds, announcing themselves quietly to anyone listening, carrying messages that might be millions of years old by the time they're heard. It's both more realistic given the constraints of physics, and somehow more lonely than our traditional science fiction dreams. Consider what it means that we might have missed our chance if 3i Atlas was indeed transmitting in 1977 and we heard it but didn't understand, didn't respond, didn't even know what we were hearing. Then the probe would have continued on. It wouldn't wait. It couldn't wait. Its trajectory was set by gravity and momentum, and even if it wanted to slow down or turn back, it lacked the fuel to do so. By the time we discovered it existed in 2019, it was already fragmenting, breaking apart as it approached the Sun, its mission, if it had one already complete or failed, depending on whether it expected a response. Now its pieces are drifting outward again, heading back into interstellar space on separate trajectories. In a few thousand years, they'll pass beyond the influence of our Sun's gravity, moving into the realm between stars where distances are measured in light years, and timescales stretch into incomprehensible futures. If those fragments carried any record of their passage through our system, any data collected about Earth and humanity, that information is leaving with them, bound for destinations we can't predict and will never know. But perhaps the hypothesis is wrong. Perhaps the correlation between 3i Atlas and the WOW signal is indeed coincidence, a case of humans seeing patterns where none truly exist, because we're pattern-seeking creatures desperate to find meaning in random events. The skeptics make valid points. The trajectory calculations have large uncertainties. No mechanism explains how a comet could produce a narrowband signal. The recent detection of normal cometary emissions from 3i Atlas, rather than anything anomalous, suggests it's behaving exactly as a natural comet should. If the hypothesis is wrong, what does that mean? It means the WOW signal remains unexplained, one of those cosmic mysteries that may never be solved. It means 3. Atlas is simply what it appears to be, an ancient chunk of ice and rock ejected from some distant star system, tumbling through the galaxy until gravity brought it briefly through our neighbourhood. It means we're back where we started, with a famous signal from 1977 and no clear explanation for its origin. But even if the specific hypothesis is wrong, the questions it raises remain valid and important. How many interstellar objects pass through our solar system undetected? What are the chances one of them might carry technology from another civilization? How would we recognize such an artifact if we found one? Should we be looking more carefully at these visitors, studying them more thoroughly while they're close enough to observe? The broader context matters here. Until 2017, we had never confirmed a single interstellar visitor. Now we've found 3 in just a few years, and we suspect many more have passed through. Unnoticed estimates suggest dozens or even hundreds of interstellar objects traverse the inner solar system every year, most too faint or too far from our observational programs to detect. We're only beginning to understand this population, to recognize that the space between stars isn't a perfect void, but contains wanderers, exiles from other systems, messengers carrying information about distant worlds. Each one of these objects is precious scientifically. They're samples from other star systems, places we'll likely never visit in person. Their chemistry tells us about conditions around other stars. Their trajectories hint at the dynamics of planetary formation elsewhere in the galaxy. And yes, just maybe, one of them might someday prove to be more than natural, might show signs of artificiality that we can't explain away as unusual but natural phenomena. The search for extraterrestrial intelligence has traditionally focused on radio signals from distant stars, looking for deliberate transmissions across interstellar distances. But perhaps we should also look closer to home, examining the objects that visit our solar system for signs they might be more than they appear. This is part of what Loeb's Galileo project aims to do, to study both distant signals and nearby objects with open minds and rigorous methods. Whether 3i Atlas is related to the WOW signal or not, this episode in Scientific Inquiry teaches us something valuable about how to approach mysteries. We need both the bold hypothesis makers willing to suggest controversial possibilities and the careful skeptics who examine those claims rigorously. We need people asking what if and people asking but how. Both roles are essential for science to function properly, to remain both imaginative and grounded. So we're left in that space of not knowing, which is where science lives most comfortably despite how uncomfortable it makes the rest of us. The correlation exists, the mathematics point to something worth noting, but the mechanism remains unclear and the evidence incomplete. Future observations might clarify matters, or the mystery might persist. Another cosmic question mark added to the long list of things we wonder about under dark skies. Let the uncertainty settle over you like a gentle blanket. Not knowing is not failure. It's the natural state of exploration, the admission that the universe is vast and complex and refuses to yield all its secrets easily. And there's peace in that acceptance, in letting go of the need for immediate answers. The cosmos will reveal what it reveals in its own time. Let's drift now into something more personal, into why mysteries like this matter so deeply to us as we lie awake in the darkness, wondering, there's something fundamentally human about the WOW signal and its possible connection to 3i Atlas. It's not just about the science, though the science is fascinating. It's about our place in the universe, about whether we're alone or part of something larger, about messages that might be calling to us from beyond the familiar boundaries of home. Think about Jerry Eman in that moment back in 1977, sitting at his desk reviewing printouts, suddenly encountering something that made him write that single word of astonishment. That moment connects to something deep in the human experience, the recognition of pattern, the possibility of meaning where before there was only noise. We're pattern-seeking creatures. We look at clouds and see faces, we gaze at constellations and imagine stories, we listen to static and hope for voices. This isn't a flaw in our thinking, but rather something essential to how we understand the world. For thousands of years, humans looked up at the night sky and wondered if anyone else was looking back. Ancient philosophers debated whether other worlds existed beyond our own. Medieval theologians argued about the plurality of inhabited spheres. Science fiction writers imagined contact with distant civilizations. And then, in the 20th century, we developed the technology to actually search, to listen for signals that might indicate we're not alone in this vast cosmic ocean. The WOW signal represents one of those rare moments when the search seemed to yield something, when the universe appeared to answer back, when the silence was broken by something that looked remarkably like a deliberate transmission, and then the frustration of never hearing it again, never being able to confirm what it was or where exactly it came from. It's like a conversation that starts but never continues, a story that begins but has no middle or ending. What makes the 3i Atlas hypothesis so compelling emotionally, regardless of whether it's ultimately proven correct, is that it offers a narrative that connects the pieces. It gives the WOW signal a source, a messenger, something tangible rather than abstract. It transforms the mystery from we heard something unexplained to we heard something from this specific object that passed through our solar system. Even if the hypothesis is wrong, the human desire for that kind of narrative resolution is powerful and understandable. We want stories to make sense. We want mysteries to have solutions. We want the universe to be knowable rather than fundamentally ambiguous. But reality doesn't always cooperate with these desires. Sometimes signals arrive without clear sources, sometimes correlations emerge without causation. Sometimes the universe presents us with puzzles that remain unsolved, not because we're not clever enough, but because the evidence simply isn't sufficient to reach definitive conclusions. There's a particular kind of humility required to sit comfortably with uncertainty. In our daily lives, we're surrounded by things we understand or can quickly learn about. We flip a switch and lights turn on. We press buttons and machines respond. We ask questions and receive answers, but the universe at large doesn't work that way. It doesn't provide clear answers on demand. It reveals itself slowly, partially, often ambiguously. Right now, as you lie there in the quiet darkness, the fragments of 3 Atlas are continuing their journey outward from the Sun. They're moving at roughly 40 kilometers per second relative to our solar system, which seems extraordinarily fast by human standards, but is glacially slow on cosmic scales. Those fragments will take tens of thousands of years to travel even 1 light year. They'll drift through the space between stars for timescales that dwarf all of human history. Maybe in 1 million years, they'll pass by another star system. Maybe someone there will notice them, study them, wonder about their origin. And somewhere in the archives, that original computer printout from August 1977 still exists. Jerry Eamon's red pen marking still visible, that exclamation of wonder preserved. It's a physical artifact connecting us to a moment when something unusual happened, when the universe seemed to speak in a way we couldn't quite understand. The search continues. Telescopes scan the skies. Radio dishes listen. Astronomers track interstellar objects as they pass through our solar system. Scientists propose hypotheses, some conservative and some bold, all trying to understand what we're seeing and what it means. This is how knowledge advances slowly, through accumulation of observations and careful reasoning, occasionally interrupted by surprising discoveries that force us to reconsider what we thought we knew. Perhaps someday we'll have a definitive answer about the WOW signal. Perhaps we'll discover its source beyond any doubt. Perhaps we'll find clear evidence of technology on an interstellar object. Or conversely, we'll identify a natural explanation that accounts for all the signal's characteristics. Or perhaps it will remain forever ambiguous, one of those cosmic questions that our generation encountered but couldn't fully answer, leaving it for future astronomers with better instruments and broader knowledge. All of these outcomes are acceptable. All of them are part of how science works, how understanding grows across generations. We don't need all mysteries solved in our lifetimes. We can rest comfortably knowing that the search continues, that curious minds are still asking questions, still looking up at the stars and wondering. Let that thought settle over you as sleep approaches, that sense of being part of something larger, a species that asks questions even when answers don't come easily. And so we find ourselves here, in late 2025, watching this story unfold in real time as 3I Atlas continues its journey through our solar system. The comet reached perihelion, its closest approach to the Sun, on October 30th, just weeks ago, as you lie here listening. Astronomers around the world trained their instruments on it during this crucial passage, knowing this would be their best opportunity to study the object while it remained bright and active enough to observe clearly. What they've found adds layers to the mystery rather than resolving it cleanly. Radio telescopes in South Africa, part of the Meerkat Array, successfully detected emissions from 3I Atlas in late October. The team led by astronomer DJ Pisano identified spectral lines at specific radio frequencies, 1.665 and 1.667 GHz. These are the signatures of hydroxyl radicals, OH molecules that form when water ice sublimates and breaks down in the harsh environment near the Sun. This is exactly what you'd expect from a normal comet undergoing typical cometary activity. The molecules are there, the chemistry makes sense, the emissions match predictions for natural processes. For those hoping the WOW signal connection would be confirmed through new radio observations, this detection was somewhat anticlimactic. No narrowband, artificial-looking transmission, no anomalous signals requiring exotic explanations. Just the quiet hiss of chemistry, of ice turning to gas, of molecules spinning and radiating energy at their natural frequencies, the universe being itself. Mundane and magnificent in equal measure. Yet Loeb and others following the hypothesis note that absence of evidence isn't evidence of absence. If there was a transmission in 1977, it could have been a one-time event, or directional, or dependent on conditions that no longer apply now that the comet has fragmented and its geometry has changed. The lack of unusual signals now doesn't definitively disprove that something unusual happened decades ago. It simply fails to provide the supporting evidence that would make the hypothesis more compelling. Recent images from observatories around the world show Three-Eye Atlas with complex jet structures, those streams of gas and dust erupting from its nucleus as solar heating activates different regions of ice. Some of these structures appear unusual, prompting continued speculation about whether the comet's behaviour is entirely typical. But comets are diverse objects, each one slightly different in composition and structure, and what seems unusual might simply be within the range of natural variation we haven't fully catalogued yet because we've studied relatively few comets in such detail. The debate continues in academic papers, blog posts, social media discussions, and conversations at observatories and conferences. Some scientists have praised Loeb for asking bold questions and bringing attention to interstellar objects as worthy subjects of intense study. Others have criticised what they see as premature speculation, arguing that calling everything anomalous and potentially artificial without exhausting natural explanations damages the credibility of serious SETI research. Both perspectives have merit. Both represent necessary voices in how science evaluates extraordinary claims. What's clear is that Three-Eye Atlas has sparked a conversation that extends beyond this one object. It's made people think about what interstellar visitors might mean, how we should study them, what evidence would be sufficient to conclude something is artificial versus natural. These are important questions that will only become more relevant as we detect more of these objects in coming years. The Vera C. Rubin Observatory, coming online soon, will revolutionise our ability to detect interstellar visitors. Its wide-field survey capability means it should find dozens, perhaps hundreds of these objects over the next decade. Each one will be an opportunity to study chemistry from other star systems, to refine our understanding of how planetary formation works elsewhere in the galaxy, and yes, to search for signs of technology if any such signs exist. We're living through a transitional moment in astronomy. Until 2017, interstellar objects were theoretical. Now they're real, observable, something we track and study. In a decade they might be routine, catalogued by the hundreds, each one teaching us something new about the galaxy we inhabit. What seems extraordinary today may become ordinary tomorrow, not because the objects themselves are any less remarkable, but because our context has expanded to include them as part of the expected universe, rather than surprising visitors. Right now, as November 2025 continues, Three-Eye Atlas is moving away from the Sun, heading back toward the outer solar system and eventually interstellar space beyond. Its brightness is fading as distance increases. Soon it will be too faint for most telescopes to track. Eventually it will vanish from our observations entirely, returning to the darkness between stars where it spent millions of years before its brief passage through our neighbourhood. The window for studying it is closing, and once it closes, we'll be left with whatever data we've gathered and whatever conclusions we can draw from those observations. There's something poignant about that, about the temporary nature of these encounters. We get a few months, maybe a year, to study these visitors before they're gone forever. No second chances. No follow-up missions catching up to them decades later. Just a brief window of opportunity, and then they're gone, carrying whatever secrets they hold back into the vast cosmic ocean. Whether Three-Eye Atlas is related to the WOW signal may never be definitively proven or disproven. The evidence might simply remain ambiguous, subject to interpretation depending on how conservative or speculative one's approach to the question happens to be. And perhaps that's all right. Perhaps some mysteries are meant to remain open, invitations to continued wonder rather than closed cases with definitive answers. The universe doesn't owe us clarity. It presents itself as it is, and we do our best to understand, knowing our understanding will always be incomplete. Let the uncertainty be comfortable rather than frustrating. Let the ongoing nature of this investigation be a reminder that science is a process, not a destination. Questions lead to observations that lead to more questions. The cycle continues, and somewhere in that cycle, understanding deepens even when definitive answers remain elusive. As 3I Atlas fades from view, the mystery it represents, whether real or imagined, continues to invite contemplation. As we drift deeper into this late night, let's step back and consider what this story reveals about our relationship with the cosmos and the nature of discovery itself. There's a particular kind of beauty in how this mystery unfolded across time. In 1977, when Jerry Eman circled those characters on a printout and wrote his exclamation of wonder, the world was a different place. Personal computers were rare luxury items. The internet didn't exist in any form we'd recognise. We hadn't discovered a single planet beyond our solar system. The idea that objects from other star systems might visit us was purely theoretical, something astronomers suspected but had never confirmed. And in that context, the WOW signal arrived, a transmission that seemed to come from nowhere, pointing toward questions we barely knew how to ask. Fast forward to 2019, and our understanding has transformed dramatically. We found thousands of exoplanets orbiting other stars. We know planetary systems are common, perhaps universal. We've detected not one but 3 confirmed interstellar objects passing through our solar system, with many more suspected in archival data. The universe we inhabit in 2025 is far more dynamic, far more connected than the universe we imagined in 1977. And suddenly, what seemed impossible then, that an interstellar visitor might have transmitted that signal, becomes at least conceivable now. This transformation in context matters deeply. Science doesn't happen in isolation. Each discovery builds on previous knowledge, changes what questions we can meaningfully ask, alters what hypotheses we can seriously entertain. Avi Loeb's suggestion that 3I Atlas might be connected to the WOW signal could only be proposed after we knew interstellar objects existed and visited us regularly. Before 2017, such a hypothesis would have been dismissed immediately because one of its fundamental premises, that interstellar comets pass through our system, hadn't been confirmed. Now that premise is established fact, and the hypothesis, whether ultimately correct or not, becomes legitimate to explore, think about the scales involved here. 3I Atlas travelled through interstellar space for perhaps millions of years before arriving in our solar system. If it carried any kind of technology, any embedded probe or transmitter, that technology would have been built by beings who lived and died long before Earth had humans, perhaps before Earth had complex life at all. The journey itself spans timescales that dwarf civilizations. We measure our history in thousands of years. These objects measure their journeys in millions. And if such a probe did send a signal in 1977, consider the patience it implies. It's travelling through the galaxy, not in years or decades, but in epochs. It arrives at a star system, tests for response, and continues on whether anyone answers or not. No expectation of immediate conversation, no possibility of real-time dialogue across distances measured in light years. Just a patient broadcast, a hello cast into the void, repeated at each star it passes over timescales longer than recorded history. This is utterly unlike the dramatic first contact scenarios of science fiction, where alien ships arrive with fanfare and immediate communication ensues. This is slow, patient, perhaps even melancholy. A message sent, a messenger departed, both passing like ships in a vast night with only the briefest moment of potential connection. We may have heard it. We certainly didn't understand it in time to respond, and now the moment has passed, the opportunity gone, the wanderer continuing its eternal journey. Right now, in mid-November 2025, 3I Atlas is visible again in Earth's pre-dawn sky after passing behind the Sun from our perspective. Astronomers are capturing images showing its tail growing longer as it moves away from perihelion, that closest approach to the Sun. On December the 19th, it will make its nearest pass to Earth, about 270 million kilometers away, still extraordinarily distant but close enough for detailed observations with large telescopes. This will be our last good opportunity to study it before it fades beyond detection, returning to the darkness between stars. Whatever we learn in these coming weeks will be all we ever know about this object. There are no follow-up missions planned, no spacecraft capable of catching it. Once it's gone forever. And this highlights something fundamental about astronomy. We study the universe at a distance, catching brief glimpses of phenomena that continue whether we observe them or not. Unlike laboratory experiments we can repeat, cosmic events happen once, on their own schedule, and we either observe them or we don't. The universe doesn't wait for us to be ready. Let this perspective settle gently over you. We're small, brief, watching a cosmos that operates on scales we can barely comprehend, and yet we watch, we wonder, we ask questions, we build telescopes and train them on the sky. We mark unusual signals and debate their meaning across decades. We calculate trajectories backward through time. We imagine possibilities. This is what makes us human. This curiosity, this refusal to accept ignorance passively, this determination to understand even when understanding comes slowly or incompletely. The story of 3I Atlas and the WOW signal, whether they're truly connected or not, reminds us that the universe still holds mysteries, that discoveries still await, that the cosmos continues to surprise us. Let that thought be a comfort as sleep approaches, that sense of living in a time of exploration and wonder. And so we come to the end of our journey through this mystery, this story of signals and visitors, of questions asked across decades and answers that remain tantalizingly uncertain. As you lie there now, perhaps on the edge of sleep or already drifting through its early stages, let's take one more gentle look at what all of this means, what it tells us about ourselves and the universe we call home. The WOW signal still exists, preserved not in space where it originated, but in archives, in that computer printout with Jerry Eamon's red pen marking, in papers and discussions that have continued for nearly 50 years. It represents a moment when the universe seemed to speak, when something arrived that we couldn't explain, couldn't repeat, couldn't fully understand. That moment hasn't gone away. The mystery persists. 3I/ATLAS continues its journey outward, its fragments separating slowly as they coast beyond the inner solar system. Within a few years, it will cross the orbit of Neptune, the last major planet in our solar system. Beyond that lies the Kuiper Belt, that realm of frozen objects at the edge of the sun's influence. And beyond that, interstellar space, the vast dark between stars where this visitor spent millions of years before arriving here. It will return to that darkness, carrying whatever it witnessed during its brief passage through our neighbourhood, and we'll never see it again. Whether these two things are connected, whether the signal and the visitor are part of the same story, or merely coincidentally linked by mathematics and our desire for pattern, we may never know with certainty. The evidence is suggestive but not conclusive. The hypothesis is bold but unproven. The debate continues, and perhaps it always will. But let that uncertainty be comfortable rather than frustrating. Not all mysteries need solutions. Not all questions demand answers. Sometimes the wondering itself is valuable. The act of looking up and asking what if, and how could this be, and what does it mean? These questions shape us as much as any answers we might find. Think about the vast spans of time involved here. The WOW signal travelled from its source to Earth, crossing whatever distance separated them, arriving in 1977 when the world was younger, when our technology was simpler, when our understanding of the cosmos was more limited. If 3I Atlas sent that signal from 10 astronomical units away, the radio waves took about 5 hours to reach us, moving at the speed of light across the darkness. 5 hours for a message to travel from messenger to receiver, and then 42 years for us to realise the messenger might have been there at all. And before that signal, before that moment in 1977, 3I Atlas had been travelling for ages beyond comprehension. If it came from a star system 10 light years away, which is very close by cosmic standards, and travelled at 40 kilometers per second, the journey would have taken roughly 70,000 years. 70,000 years drifting through the cold and dark, through the space between stars where no sun warms you and no planets pass nearby, just endless night, and the patient pull of distant gravity gradually shifting your trajectory, bringing you eventually to another star, another brief moment of warmth before the journey continues. Imagine being that patient. Imagine time meaning so little that 70,000 years is acceptable transit time between destinations. We humans live for decades if we're fortunate. Our civilizations last for centuries, maybe millennia. 70,000 years ago, Our ancestors were just beginning to spread beyond Africa, learning to navigate new continents, creating the first art and music and stories. All of human civilization has risen in the time it might take for an interstellar object to drift from one nearby star to another. This perspective, this cosmic sense of scale, puts our lives in context. We're brief. Our concerns are temporary. The mysteries we contemplate tonight will outlast us, will be pondered by future generations with better tools and broader knowledge, and that's all right. That's how it should be. We don't need to solve everything in our limited time. We just need to ask good questions, observe carefully, think deeply, and pass what we've learned to those who come after. Right now, wherever you are, whatever room holds you as sleep approaches, you're part of this cosmic story. You're made of atoms forged in ancient stars. You're breathing oxygen created billions of years ago. You're lying on a planet orbiting a sun in a galaxy containing hundreds of billions of other suns. And somewhere out there, far beyond our ability to see, 3i. Atlas continues its journey, and perhaps other visitors are approaching, bearing their own mysteries, their own possibilities. The search continues. Telescopes listen. Astronomers calculate and observe and wonder. The questions persist. And somewhere in all of that, there's beauty, there's meaning. There's the simple, profound fact that we're here, we're aware, we're capable of contemplating our own existence and the vast cosmos that contains us. Let that thought be the last thing you hold as consciousness fades. You are part of something larger. The universe that created you contains wonders beyond imagination. Mysteries remain. Questions echo across space and time. And that's perfectly, beautifully, peacefully all right. Sleep well. Dream of stars if you dream at all. And know that when you wake, the cosmos will still be there, still mysterious, still magnificent, still waiting for minds like yours to wonder and explore and ask what might be possible in all that vast darkness between the points of light. Good night.